How do these profiles help in understanding the internal components, passivation layers, charge transfer, diffusion, and Warburg resistance within the electrolyte system? How can EIS results be used to assess the internal resistance caused by interfacial compatibility, particularly between separators/electrolyte and electrolyte/electrode? And why is this important for evaluating the overall electrochemical performance of the electrolyte? How does the ionic conductivity of a liquid electrolyte get determined using a conductivity meter, and why is it important to use a DC voltage in this measurement? Can Davis Zurns manufacture solid-state sodium-ion batteries made from seawater in Latvia? What does a typical EIS profile of sodium-ion detachment and embedding processes in an inlay electrode consist of, and how are these components used to analyze the behavior of sodium ions during electrochemical reactions? How do these characterization techniques, CV, LSV, and EIS, complement each other when studying liquid electrolytes, and what does each technique reveal about different aspects of the electrolyte's electrochemical properties? In what way does understanding the electrochemical stable windows ESW, internal resistance, and ionic conductivity help in optimizing the performance of liquid electrolytes for use in energy storage devices such as sodium-ion batteries? What is the significance of the ultra-high frequency region in an EIS map, and what role does the ohmic resistance associated with the transport of sodium ions and electrons through components like the electrolyte, porous septum, wires, and active material particles play in this region? How is this process represented, and why is it important to consider the ohmic resistance, RS, in the interpretation of the EIS results? In the high-frequency region, what does the semicircle represent, and how is it related to the diffusive migration of sodium ions through the insulating layer on the surface of the active material particles? What is RCI, and how does it describe the resistance of sodium-ion diffusion migration through SEI films, and why is this important in understanding the electrochemical behavior of the system? How does the mid-frequency region relate to the charge transfer process, and what is the significance of the semicircle in this region? How is RCT, charge transfer resistance, and settled double-layer capacitance represented in this region, and what do these parameters tell us about the electrochemical reaction and the electric double layer at the interface? In the low-frequency region, what does the diagonal line represent, and how is this related to the solid diffusion process of sodium ions inside the active material particles? How is the Warburg impedance, CW, used to describe diffusion in this region, and why is it important to understand the solid-state diffusion process?